All righty, let's get going. We're going to talk about Kubernetes and containers. My name is Ola, and I'm going to spend at most an hour. I want to make this short and sweet and to the point, and give you enough knowledge about containers and Kubernetes so that you could sound knowledgeable if you end up in an elevator with somebody asking you about containers and Kubernetes. That's kind of what I'm aiming for. Like, I'm going to make it through this, elevator ride, and I will sound like I know everything about containers and Kubernetes. So again, my name is Ola. You can find me on Ekdal is my last name. Find me on LinkedIn if you want. Not too many with that particular first last name combination, so I'm sure you'll find me. Um, Quick thing about myself, from Sweden originally, don't live there anymore, live in Irvine, and have been in the software engineering world since late 90s, so quite a few years now. Done all kinds of things. Started out as doing Java development and then worked with a bunch of different technologies and platforms. And lately, it's a lot of DevOps and clouds and automation and containers and Kubernetes. So what I wanted to show you here before we get going is the end result. This is what we're going to work our way up to. So what you're looking at right here might not seem very exciting. It is a little app that is deployed, and it's just a little demo app, so it doesn't really do anything, but it has a few different endpoints here that I can navigate to. And what you're looking at is a containerized application deployed into a Kubernetes cluster. The Kubernetes cluster is running in a cloud, in AWS, to be specific. So I'm going to walk you through the process of starting off with an application that is just running on my local laptop. And then we're going to put that into a container. And then we're going to talk a bit about that process. We're then going to deploy it into Kubernetes, but Kubernetes that is running locally on my laptop. And once we've done that, we'll take that app and we put it into what you're looking at here. We put it into Kubernetes running in the cloud. So the application and everything that I'm showing you here, I should mention, is available in a GitHub repo. Let me grab that link real quick. This right here is the repo. Feel free to go and check it out if you want. It has everything that I am showing here in this particular demo. And the application itself, it is a Python application. And it looks like this. Now, it doesn't really matter the fact that it's a Python application. This is not a programming session. I'm not going to talk about writing code. So you don't need to know Python to understand how all of this works. It could have been just about any language. It could have been Java, C++, any of the .NET languages, etc. It doesn't necessarily doesn't have to be a web application either. What I have is a little simple web API, but it could have been just some, background process, something written in, I don't know, C++ that is not at all being interacted with over HTTP, but just some process that is running that, moves some data around or archives files or whatever that process happened to be doing. So it's just something that runs that is written in some programming language. And this right here is something that I can run on my local machine, obviously. And it is specifically a application using something called Fast API. Again, it's all done in Python. And if I wanted to go ahead and run this on my local machine, I can go ahead and do that here. We'll go ahead and start it. And it is going to run on port 8000. And if I were to open up a browser, and then if I were to refresh, there is the application. As you can see, it's the exact same application that I just showed you, this one here, that is running in the cloud. This is the same thing. It's just running on my local machine. Right now, it is just the application itself that is running. In other words, there is no containers, there is no Kubernetes involved at all. It's just the Python app that is running on my local machine. Now, what I'm going to do is I'm going to containerize this application. Why do I want to do that? What's the benefits of doing that? And then how would I go about actually doing so? Let's go ahead and draw a little picture. So if I have an application, if I have code that I want to run, and again, this could be anything, right? It doesn't have to be a web application. It could be any language, anything that I need to run on any operating system, laptop or a desktop or a big server, on-prem to cloud, doesn't matter, something that's going to run an application, right? That application is most likely going to have some dependencies that needs to be available for the application to run. Like it's going to need an operating system, and then it might also need some additional software dependencies. So in my case, for example, when I'm running my Python app, then it is a Python application. So it's going to need a Python runtime, but that in itself, it is not going to be enough. I can show you here. If I were to try and run, this is the exact same command that I issued earlier to run my application. What I did was I tried to execute this command again, but I'm doing so in an environment where I do not have the correct software dependencies available. So Python is there, but the application is going to also need something called UVcorn. It is then also later on going to need something called Fast API. It's not important to understand exactly what those things do. Just understand that they are dependencies. They are software packages that needs to be available. And that is something that is going to be required for my application to run. And that is very, very typical, right? That whatever application you have written in whatever language, whatever it happens to do, it is going to need dependencies. Now, why do I make a big deal about these dependencies? Well, they need to be installed, right, on the system. All right, no big deal. Let's go ahead and install the dependencies. Sure, I can do that. I've done that when I showed you how to run this. Let me fire up that environment again. So I'm going to get my environment here going. And oh, sorry, I'm in the wrong folder. I need to go up one folder. There we go. So I'm going to, there we go. I'm going to activate this environment. And now if I do so, I can go back and I can rerun that command again. And now it works, okay? Again, because I started an environment where, again, it's not just Python, but it has these dependencies. So I could, let's say that I had other dependencies that were required. This is going to be a little bit different depending on which language you use. But in Python, I can install whatever dependencies that are going to be necessary. I can install them using a tool called pip. I could say pip install and then the name of the dependency, right? So at some point, I ran pip install and fast API, right? That is one of the dependencies. Here it just says, hey, you already have that. There's nothing to install. But if it wasn't there, it would install it. At some point, I went ahead and I said, I need to install this other thing called UVcorn, right? Again, it says you already have it. There's nothing to install. But if it wasn't there, it would install it. And I could go on and I could install a lot of dependencies. right? Pretty straightforward. Now, this is for one application, a very simple application. So let's say that I now need to manage 10 applications or 20 applications or 100 applications, right? All of a sudden, there's going to be lots of dependencies that I need to manage. Also, I might run into situations where application A says, hey, I want version 3 of this dependency. And then there is another application that is saying, I want version 4. And then another one that says, hey, I want version 1. And I now need to manage all of those different versions. Not impossible. I can absolutely do that. But the point is that it adds a little bit of complexity to adding all these different dependency versions. So what I can do to simplify this a little bit is I can tell my developer folks, or if I'm the developer, I can tell myself, how about instead of just saying, here's the app, and it also requires these things to be available, how about if I were to create something that contains not just the application code, but it also includes all of the dependencies. I package all of that up. So I figure out what my dependencies are and the application and any other types of configurations that is going to be necessary for my application to function. Like, hey, what port numbers is this application listening on? If there's anything related to like security configurations and just, quote unquote, stuff that needs to be set up and configured in a certain way. How about I do all of that and I deliver that in, let's for now just call it a package. Right? Here is the package. And then whoever is responsible for running applications says, awesome, I'm just going to take this package, and each package is independent from other packages. So I could have package A containing an app and some set of dependencies. We have package B, we have package C. And we can take these packages and then we have some sort of runtime that understands how to run these individual packages, right? So there is something that is available on a server somewhere, and I'm just going to call this like a runtime for now, that understands how do I run these individual packages that are giving to me, that are being given to me. So what I'm describing here is the process of creating what we call an image, okay? So this here is an image, this here is an image, and this here is an image, okay? So I create these images, and then later on, I can create an instance, or 2 instances, or 3 instances of an image. And these instances, they are the ones that I am actually running. So what I should do is I should rewrite this a little bit. What I should do is I should put my runtime over here. And I should then draw it like this. I would say, okay, I need to run this image C. I'm going to create an instance of that. And again, you can create multiple instances of an image. You could say, I want 3 instances, behind a load balancer, etc. But I'm going to create an instance of that particular image. I can create an instance of this other image and give that to this runtime. And these instances, those are the things that are actually running. We call these things containers. So what you're creating, these packages are called images. The images themselves, they are not the things that are running. You create an instance of an image, and that is called a container. Okay. And the idea here is that, just to recap a little bit, if I can describe everything that is necessary for my application to function and put this in this independent by itself package that can run as an instance. We call a container. All these things can run side by side. They can have their own dependencies and versions, etc. And the only thing that's necessary somewhere is to have a runtime available on a server somewhere, a Linux server, that understand how do I run these instances of all of these containers. So again, I'm describing here an image. In an instance of an image, the thing that's running, that's called a container. There is a standard for all of this. This is not some proprietary technology. There is a standard for how all of this works. Like if you wanted to find out sort of the nitty-gritty details of, well, how do I actually create an image? Like, what is the binary makeup of an image? Like, what does it need to look like? There is a standard for that. This runtime that you're talking about, like how does that work? Like, what does that runtime look like? Right? What is it that it needs to be able to do and understand in order to function? There is a standard for that. It's all part of the open container initiative. Like, you don't need to know the details of this to work with containers and Kubernetes, but this is what it's all based on. You might have heard about Docker. So Docker is a company, and Docker has been very instrumental in the advancement of how images and containers, how that works. They have contributed a lot. They've open sourced a lot of things that they have, a lot of technologies that they have come up with. And they are one of the sort of driving forces behind the open container initiative. But one thing that I just want to highlight here is that Docker is not synonymous with containers. A lot of times people say Docker container. I'm going to create a Docker container. You can use tools from Docker to create containers and runtimes from Docker that can help you create images. That's what you create. And runtimes that help you run instances of images to containers from Docker. Very common to do that because they have good tools that make it easy to use. But there are other alternatives, okay? There is things like Podman and Rancher Desktop and Containerd, and there's other ways of creating images. There's other runtimes available besides Docker runtime to run container instances. And it's all based on these standards. So I can create an image using Docker tools, and it can use a runtime, not a Docker runtime, but one of these other runtimes, again, because it's all based on these standards coming from the Open Container Initiative. So how do I go about, like, how do I actually build this package? Like, how do I create the image, right? Well, I'm going to use Docker tools. Again, very common that you do this because it's easy to use, readily available, and you're going to create a Docker file. That's literally the name of the file. And inside of here, you are going to give instructions for how do I assemble this package? How do I assemble the image? Okay, that is the purpose of this file. So what I'm saying, starting from the top here, is that, hey, I'm going to run some Python code. So I'm going to need a Python runtime. So I'm saying that at the very top, from Python 3.12-lim, that indicates I need a Python runtime. Now, okay, so where does that come from? Like, I understand it's Python, but what is that? Okay, well, by default, if you are just saying that, hey, I want from something, what you're referencing here is a base image. You're saying that, hey, I don't necessarily gonna need to build my image completely from scratch. I want to layer my application on top of some existing image that has like the rudimentary components of like getting Python to run, right? So I'm going to use that base image, and then I'm just going to put my app on top of that and configure a few things, and then I'm ready to go. So that base image, if you don't explicitly specify otherwise, it is going to come from it's called a container registry, even though technically we're storing images. And this registry, again, by default, unless you explicitly say otherwise, it is going to be maintained by Docker. It's called the Docker Hub. And inside of here, there is going to be thousands and thousands and thousands of base images that you can work with. Again, depending on what language that you want to run inside of your images. And you can get images, base images with like databases, Postgres, MySQL, etc. Installed. So if you wanted to do something with a database, you can just pull an image that has the database configured already, and then you can just tweak some of those settings, load it with data, and deploy it as a container, and now you have a database. So if I were to go in and if I just search here, you can see that I've searched already for Python. So if I go ahead and I search for Python, there is going to be official Python images. Note here, anyone can publish into Docker Hub. So as an organization, as a company, there's typically going to be a process where you scan images, probably even these official images. So there is tools that you can put in place that scans images for vulnerabilities and checks and make sure that there's not something quote unquote bad that makes it into your environment in the form of a kind of like a Trojan horse inside of an image, right? So from here, there's going to be this big registry repository, and there's going to be a bunch of different options here for various Python images, base images, different Python versions, and other types of configurations. So right there that's the one I'm using, I think, right? 312 Slim. I think that's the one. Yeah, and you can see that this one is actually created by its own Docker file. It's right here. This is how my base image was created. I didn't do this. This is something that is provided for me to use. This is how that base image was created. So I can go in and I can see exactly what was added onto that one particular image. So this is what I'm working with. So I'm now going to say, all right, I got my Python stuff. So what I want to do now is I want to create a what's called a working directory. So this is in, like, once the container runs, there's going to be a folder in there called app. And I am copying this requirements. This is a Python way of saying that, hey, my app, it's dependent on these things. And then I am going to run pip install and say, hey, on that image that I'm building, I want you to install my software requirements. They're listed in that requirements.txt file. And once we've done that, we're going to copy, I simplify here, just ... It could really just be like app.py as well if I wanted to. And I'm now going to copy my app.py into that app folder. Again, app.py, that's kind of the main, my main application. And then I'm also going to say that, hey, I want to make it so that you can communicate once I have my container running on port 8000. The reason why it's 8000, that's just the port that I picked to run this particular app. I could have picked any port, right? And then I'm saying, all right, once we have copied everything over, we installed the requirements, here is the command to, like, once we create a container instance, here is the command to actually run my application, okay? So this is just a file. This in itself doesn't do anything. So what I'm going to do now that I have that file available, I'm going to build my actual image, okay? So I'm going to use, again, there's other options for this, but Docker is very commonly used. So I'm going to go ahead here and I'm going to build my image. So I'm saying Docker build And then I'm going to make sure that I pull the latest version of that base image. And then I'm going to make sure that I remove, there's this process that Docker goes through and it creates this intermediate, what's called layers. And I'm just saying, essentially, at the end of this build process, once we have the final image, then just discard of all this intermediate stuff. And last thing here is I'm going to give this a label or a tag. So -t or -t is going to be a tag. Now, I can call this whatever I want. I'm going to call this one Wednesdays, because I'm going to run these sessions every Wednesday. I could call it banana if I wanted to. And then there's also going to be a version number. So I can have different versions of my image, version 100, 101, 102, 1.1, etc. Following a typical sort of semantic versioning scheme. And then lastly here, I'm going to do a dot at the very end there. So the dot here just indicates that, hey, the Docker file, I'm in this folder. The Docker file that you're looking for, it's in this folder. It's going to go and look for a file with that name, Docker file. So now if I hit enter here, what is going to happen is it's going to go and it reads my instructions. Oh, okay, you need this base image, you need to copy over, you need to install things. I'm going to do all those things for you. And at this point, what I have is an image, okay? And there's nothing running yet. I have an image. I can create an instance of that image, like the container, but nothing is running yet. I've done this build step already. I tested, make sure everything works. So when I do this again, it says, hey, it looks like you already have an image that is already exactly what you're trying to do again. So I'm not really doing anything. I'm just going to say, hey, you already have this image. So this step here, if I did this the first time, it would take a little bit longer. In this case, it would be kind of quick, but it would take a little bit longer for that to complete. And what I can do now is I can get a list of all of my images. So these are all the images that I have available on, this is on my local machine. So you can see that I have quite a few images available here. So one of the images here is going to be that, it's going to be that Wednesday. Oops, sorry. It's going to be that Wednesday image that I created. There it is, right? Very top. The terminal here is a little wonky. There we go. So at the very top here, there's going to be the Wednesday image. And there it is. You can see that it was created about a minute ago. That is the size of the image. So that's the dependencies, my app, and some other things. How do I go about actually creating a running instance of this? Well, we're now going to run. So I am now going to say that I am going to run an instance of my image. -d, that means that it runs as I can run it as a foreground. You can run it as a foreground process or a background process. -d would run it in the background, but I can run it in the foreground. That's fine. Just to kind of show you the output. And then I'm going to do some port mapping. I'm going to say that, hey, I want to map port 8000 to 8000. So this is kind of from the outside world mapping to something that is going to work with the container. It doesn't have to be the same port, but that's what I'm going to use here. And it is over TCP. And lastly here, we're now going to specify the image. That's the image I just built. So when I hit enter here, it is going to launch an instance of that image. That is called a container. I now have a running container instance. It runs on port 8000. So just like when I ran this initially, without just by itself, it also ran on port 8000, right? So if I refresh here, right, this is the application running. It should look exactly the same as before. We can see that it functions here. I can navigate to some of these, some of these different endpoints that I have. We see that it's functioning. And just to kind of prove here again that it is indeed functioning, what I'm going to do, since it's running in the foreground, I can just Control C to stop that process. We'll go back here, a refresh, and you can see that it's kind of thinking about it and says, hey, can't find it anymore. It's not running anymore. So I now have a image that I can create container instances of. And I have a containerized application. Now, the thing is, if I have one application or two, like less than 10, then I could probably just, let's say I want to eventually put this in the cloud, I could probably just, whatever cloud I use, pick a, set up a server. I could install a runtime that understands how to run container instances, and then just go ahead and say, hey, just, launch an instance of this container. Like, I don't involve Kubernetes at all. I sort of just manually run things, and that would probably work quite well. The challenge is, once you start to get into, well, I want to have multiple instances running behind a load balancer, and I want to make sure that if an instance goes down, then it's something that automatically spins up another instance. Oh, and also, by the way, I can't really run that on one server, because that one server then becomes the single point of failure. So I want to take across two servers. So now I need to figure out, okay, how do I coordinate? How do I orchestrate it so that I can deploy, let's say, 4 instances, and 2 ends up on this server, 2 on this server. Oh, and by the way, I probably want to put these 2 servers in different availability zones in the cloud. So again, get some more redundancy. And all of a sudden, there is all of these extra things that I now have to be responsible for. Imagine this at scale, right? If it's a handful of apps, maybe not a big deal, but once you get into the hundreds and the thousands, I mean, I have clients that I work with that have like tens and tens of thousands of container instances running. You can't really manage all of that by yourself. It's going to be not very fun. So how about if we had something where I could essentially just say, I have this image, and what I would like to do is I would like to take this image and maybe also have some sort of file, let's call it a deployment manifest, like something that just describes a bit about how I want my deployment to be configured. Like, I want 5 instances, and I want it to be spread out a certain way across different nodes. There might be some things in there about that, hey, this thing that I'm deploying, it has a dependency, some other container that is running. So I want to make sure that before this container gets deployed, that this other dependency is deployed. Or it might be that I'm deploying a database, and that database is going to be dependent on some external storage. So I want to make sure that storage is ready before I deploy my container. Like all these other things, let's just call it that, that's going to be important for my deployment to function properly. So, be awesome if I had the ability to just say, hey, here's my image, here is my deployment manifest, and then just be able to give that to something that would look at the manifest and say, no worries, I'll take care of all of that for you. I'll manage that for you. What if there was such a thing? Well, there is. And that thing is going to be Kubernetes. Kubernetes is this is how I think about it. It is a platform on which I can deploy containerized workloads. And I can tell Kubernetes that I want you to look over and manage and govern this deployment and make sure that it behaves a certain way. I want you to constantly look at all of the deployments that runs within this Kubernetes environment and make sure that if something that I have explicitly stated in my deployment manifest is not how it is at any given point in time once it's been deployed, like an instance goes down or something fails or something happens, right? Then I want you, Kubernetes, to fix it, okay? I want to make sure that everything is always in according to my deployment manifest. That is what Kubernetes is going to provide for us. And what we're going to do is we're going to take my image and we're going to deploy it, and we're going to create a manifest in which we can describe how we want the deployment to work. Now, before I do that, I just wanted to talk a little bit about Kubernetes. I say it's a platform. So it's a platform that is made up of a lot of moving parts. Okay, I'm not going to go into like details about Kubernetes architecture, but I just wanted to talk about a couple of things here that's going to be important. So first of all, a Kubernetes is made up of what we call a control plane. And then it is going to have one or more. So in my case here, I have three, what we call worker nodes. Okay. And on my control plane, there's going to be some components. One of the components here is called an API server. And when I interact with Kubernetes, like when I tell Kubernetes, hey, I have this image, I want you to deploy it, here are some things that are important. If I ask Kubernetes, hey, can you tell me your current status, or can you tell me what's deployed, or can you configure this thing that I'd like, any type of interaction that I have with Kubernetes, it is going to be through this API server. I'm going to communicate over HTTP. I make HTTP call. It's a REST API. Right? It's a RESTful API that I'm working with. So I can use any tool that can communicate over HTTP to interact with this API server. Okay. So for example, I can use, sorry, wrong one. I can use something like curl. If you're not familiar with curl, it's a tool that's been around, created by a Swede. It's been around for a very long time, and it's not at all specific to Kubernetes or containers or anything we're doing here. It's just a command line tool that I can use to interact over HTTP. What I'm doing here is I am using curl to talk to my API server. Okay. And what I wanted to point out here is that, yes, I can use curl. Let's go ahead and show you what the output looks like here. So if I were to go in, I've seen a script, oops, sorry. Right. If I were to, I am going to, so sidetrack here real quick. So what's happening here is, what it's complaining about here is that, hey, you're trying to use curl and, access this API server. And what it's complaining about here is that, well, you can't do that because I can't find the API server the way you're trying to access it. The reason why that is because I use another tool here. I'm going to explain this tool in just a bit. The reason why that doesn't work is because I have two different Kubernetes clusters that I can access from my local machine. I have a local Kubernetes cluster, and then I have a sorry, let me do it again. See if we can get that show up a little bit better. There we go. Actually, I have a couple of different Kubernetes clusters, and right now, I am using. It's pointing to my cluster in AWS, and what I wanted to show you with my curl, the way that script is set up, is to point to my my local cluster. So what I am going to do here is. I am going to, I'm going to switch over to my, my local cluster, and I am actually not seeing that in here. Let's see here. What did I do? We'll figure this out real quick. So let me go ahead and just verify. Yeah, I do have my kind cluster inside of here. All right, I'm going to take you through a little bit of troubleshooting. So what I wanted to show you was using this curl tool. And the point that I wanted to get across here is that you can, but it's not very convenient. And you need to provide ways of, because this API server is going to be not just open for anyone to talk to. So you have to provide a way of authenticating. There's different ways of doing that. The way that I am doing it is I am looking at using certificates. So again, possible, but not a very convenient way of doing things. And I wanted to then point out that what you're typically going to use is a command line tool that you would install called kubectl or kubectl. And what that tool is doing is it is going to make it a much more convenient to talk to clusters. You can have multiple clusters configured. You can switch and say, hey, use this cluster, this other cluster, right? If you have like, you know, QA, dev, prod, or you have like on-prem and cloud clusters. What I'm going to do here is I'm going to do this in another terminal window. That's going to give us a little bit more real estate to work with. What I'm going to show you here is that kubectl tool, what it's going to get its information from when it is trying to connect is going to be from a config file that is in a folder called, by default, it's going to be in a folder called .kube. So if I were to go ahead and if we were to open up that config file, a lot of this in here is going to look like a whole bunch of like gobbledygook. Like there's a lot of like certificate. This is base 64 encoded certificate information. Not important. What I wanted to show you here just is that what we have in here is going to be a number of clusters that are being listed, right? So you can see here as I scroll down, this is all different clusters that exists. What I'm looking for here is my actual kind cluster, and I don't see that. Okay, we'll try this. Just get out of here, and let's go ahead and going to switch. All right, well, let's try we'll try another thing then. We'll go ahead and we'll create a new cluster. So that actually brings me to another point here. If you want to work with Kubernetes locally, there's lots of tools available, like that makes it easy to set up um, clusters locally. So what I'm using here is a tool called Kind. This is free. If you go to the GitHub repo, I listed a couple different tools you can use. There's Kind, K3D is another one, Minikube is another one. You can pick any one of them. They're free to use. They all work great. I'm using this thing called Kind. And what I'm going to do is I'm going to create another cluster, and we'll name that this create cluster, right? Oh, that's because I do cluster one too many times. All right, Kind, create cluster. All right, we'll try it again. There we go. So what's happening here is it is creating a new cluster, and it is not going to take very long. And while that is running, let's go ahead and look at the manifest. So if you remember, I have my image. My image is created already, right? So if you remember, when I talked about Kubernetes setup, what we can give that is a manifest. This here is an example of a manifest. This is YAML. So inside of here, I am going to explain that, hey, I have an image somewhere. Here is my image. I'm going to explain what that old act of Wednesday is like. What is that reference? It's an image, and I would like to deploy that. Then there's going to be some instructions here about port numbers. There is going to be some instructions around like how many instances that I want. So I could say, you know, I want 3 instances. And then there's also, if I scroll down here a little bit, going to be some information about how I would like to expose my deployed container outside of the cluster. Because here's the thing, you might deploy things into Kubernetes that you're not necessarily going to interact with from outside of the cluster. It could be that there's some background service, like a job that you schedule to run that does something. It's not sort of users interacting over HTTP, just something that needs to run on a schedule. So you might need to access, you know, outbound out of the cluster, but not from outside into the cluster. So point here is that you don't have to make everything available or expose everything outside of the cluster. And this here, this manifest, as I mentioned earlier, this is something that now it works. This is something that Kubernetes is going to constantly monitor, like what's in that manifest, and make sure that that is actually how things are deployed. So now, if I were to go ahead and use kube control, and if I check to see, hey, what's deployed, we're going to have this one thing called a service. Ignore that for right now. essentially there's nothing deployed. Like I literally, you just saw me create the cluster. Like there's nothing created yet, right? So what I'm going to do is I'm going to deploy something. So again, I have this image. Now remember that the image, I built that image earlier. I said Docker build and then, say that, hey, here's the Docker file, right? Here's the instructions. And it exists on my local machine. Now, remember how I said that you can use this Docker Hub, like it's this centralized registry to pull images from? You can also push images to that registry. So what I have done is I have taken my image and I have pushed that into Docker Hub. You can set out, it's free. You can set up an account and you can push into, you can see that here it is. I did that earlier today, about 8 hours ago. It's the exact same image that we had on my local machine. And the reason why I did that is because it's going to make it a little bit easier for me, especially when I later on show you here in a few minutes to deploy into AWS. Because now I don't need to feel, well, how is AWS going to get to my local machine to get the image? I can just tell AWS, hey, it's in this, available registry, Docker Hub. And you can set up, and this is typically what companies would do, you can set up your own internal private registries. You don't need to use Docker Hub. This is just one example. AWS has solutions for this, Azure, Google. There is third-party companies, JFrog. There's open source alternatives. There's lots of options for setting up your own internal image registry if you wanted to. But I'm using Docker Hub. So notice there that it says Olactol, that's the name of my hub, my registry, /Wednesdays, right? This is the image, and it's version 1.0.0. So that is going to be, this right here is going to be the version that is that's going to be pulled down, right? That's right there. So that right there, if we go back and we look into here, you will see that in my deployment manifest, I am saying this is the image that I want you to deploy. Like it's pulling that from that hub. Okay, so let's go ahead and do that. So I am going to now use kube control, and I'm going to say apply -f means file, and then it's just called deployment.yaml. Like that's the file I just showed you. And I'm going to hit enter. And now if I go and I do that kube control get all, notice that it's in the process of creating 3 instances of that container. It is now down. Notice that I have my 3 containers up and running. Why 3? Well, I told it here I want 3, right? Now, check this out, okay? Let's say that, I'm going to do this on purpose, but let's say that I went in here and I can say kube control. I can say delete pod, and then I'm going to delete one of these. So these are the pod 1, 2, and 3, right? So I'm just going to take, pick a random one, right? This is this pod right here. And if I hit enter, it deletes it. But check it out. As soon as I deleted it, it spins up another instance. Kubernetes does that. Why? Well, it does it because I told it I want 3 of them. It constantly checks. And when it detects, hey, you only have 2, it spins up another instance. It's just one example of what Kubernetes is going to do. There's tons of other things, here. I mentioned some of them, right? It's not just, hey, make sure we have 3, but it's like you can distribute things on different nodes, different availability zones. There's lots of configurations and things that need to exist. And there is a lot of instructions that you can give to Kubernetes to make sure that things are running. So this right here is going to run on my local machine. Now, if I were to go in and do get all with a minus capital A, there is a whole bunch of other things that are running here. Remember how I said that Kubernetes has this control plane, and on that control plane, there's other things that are running. Well, here are some of these other things. Like here is the API server, for example. An interesting thing here is that Kubernetes itself runs not all, but almost all of its components as Kubernetes, like on the control plane, runs as containers themselves, the components. All right, so last thing here, how do I now, so this is running local, right? So how do I now get this to run in a cloud? So in my case, I'm going to deploy this into, or it has been deployed already, into AWS. I have created a Kubernetes cluster here. There's different ways that I can create Kubernetes. There's options for creating Kubernetes clusters in AWS and most other clouds. What I'm using here is a AWS Kubernetes implementation called Elastic Kubernetes Services, or EKS. So I've created this cluster already. And inside of here, again, so this is running in a data center, an AWS data center somewhere. In here, I'm going to have that same setup. There's going to be a control plane. There's going to be a working node or multiple working nodes. And I can deploy my workloads into this cluster. Now, how would I go about doing that? Well, I would actually use the exact same image. I would use the exact same deployment manifest. I do not have to change a thing inside of here. All of this can stay exactly the same if I wanted to. Now, there's one thing that I did change here. I created a deployment-EKS. And that one thing that I changed was this, right? Notice here it says load balancer, and down here it says node port. Now, what does that mean? Well, remember how I said that when you deploy something into Kubernetes, you don't have to make it available or expose it outside of the cluster. But if you do, there is options for how that is done, like how do you access the thing in the cluster. So what I'm saying when I deploy into EKS is I'm saying that, you know what, not only do I want it to be deployed into Kubernetes in AWS, I want it to be available outside of the cluster, but I also want to deploy a load balancer, like an AWS load balancer in front of my cluster that load balances traffic if I deploy multiple instances, right? I could go in and I could say, I want to deploy 100 instances of this. It's going to be 100 container instances based on this one image. Now, if I go in and let me do it from here. If I go in and if I look at my my context, I know this is super small, but what I'm doing here is I am looking at a list of clusters that I have available. The little asterisk there indicates that that is my current kind cluster that I'm working with. That's my local. That's the one that Kube Control is currently interacting with. So what I need to do now is I need to switch over to another cluster. The cluster that I'm going to switch over to is this cluster right here. Okay, that is my AWS cluster. What I'm going to do is, I know this is very small. Zoom in a little bit. What I'm going to do here is I'm going to say kube control config. I'm going to explain to that, hey, we're going to switch cluster. We're going to switch context to that right there. Okay. And now if I were to say kube control get all, okay, what is going to happen here is that, oh, isn't that great? It is not being able to connect. All right. Did I pick the wrong cluster? I'm lucky that I prepped this demo and let's see here. See, I thought I was the one. I will try this one. All right, there we go. I picked the right cluster. Okay, so notice here that, so I deployed this already, right? Earlier, before we started the session, I deployed it into the AWS cluster. I'm looking at the AWS cluster right here. One thing that I can point out to kind of prove that is, you notice here where it says external IP, this is how something is exposed outside of the cluster. Look at that URL. Like that's my load balancer URL. You can see that that is the URL that I'm using right here. That's that URL, right? Okay, so that's kind of showing that I'm connected to that cluster where things are deployed. Okay, right now, I have one instance running, one of one. Like when I initially deployed in my manifest, I said, hey, I'm going to have one single instance. What I'm going to do is I am going to switch back and do it here. I'm going to go ahead and I'm going to run or reapply this manifest. And notice there that I now have replicas 100. So it's going to go from 1 to 100 replicas, okay? Let's go ahead and do that. So let's go ahead and we will go into my folder where I have that file. So this is my deployment EKS. And I'm going to say kube control apply -f deployment EKS. Now what's going to happen here is Kubernetes is going to look at that manifest and it's going to say, well, your deployment had some changes. Like you say that you want 100 instances. I also in there describe, remember how I said I can describe how I expose something outside of the cluster? That's called a service. It says the service didn't change. So the service I'm going to leave as is from your previous deployment. This thing here changed because there is no 100 instances instead of one instance. Let's go ahead and verify that, okay? So if I go and, I guess I can type it out. If I go and say kube control get all, let's see where we're at. So you can see that it's in the process of starting up. Some of these are actually, that's an early one, right? That's the one that was running. There's a new one that is running. That one is running. It takes a little while for this to get up and running, to get all 100 of them up and running. Now, here's the other thing too that I want to point out. When I set up this cluster, I just did that specifically for this little demo. I'm going to tear this down as soon as we're done here. In other words, it's not production or anything. So I set this up as a very, very small, it's not a very large cluster. It doesn't have a ton of resources on it. So that's another reason why this is going to take a little while to get going. And you're also going to see here that it might actually be that a lot of these are going to be in a pending state. So down here, we can see that there's 13 that are ready. So there's 87 that is still in a pending state. My guess here is that that is because that one working node is saying that, hey, I'm running really low on resources. So you probably should deploy some additional nodes. And if I did that, then Kubernetes can redistribute the deployment and figure out, hey, we have additional resources. Again, it's another thing that Kubernetes can do to orchestrate the redeployment of the resources. But it is at least one that is available, right? So if I go in here and refresh, right, it's, you know, it's load balancing across those 13 that are currently running. All righty. So I know I said I was going to take an hour, and I'm at like an hour and 6 minutes. So I apologize for going a little late. But just to recap here, what I did was I took a Python application and I ran that by itself. And then I talked about how, well, this app, it has some dependencies. Be nice if I could package everything up, app plus dependencies in a way, and just run that somewhere. Well, that's where the image comes in. I can build an image. I can then run one or more instances of that image that is called a container. The thing that runs is called a container. It's all based on standards, this Open Container Initiative. So there's different tools that you can use to build and run, create images and run containers. And then I might also have a need for something that can manage all these things that are running and make sure that things gets configured and things are up and running. And if this is stopped, start another instance. And that is what Kubernetes can help us with. And it's a platform, and I can, on that platform, deploy images by saying, here's an image, here's the manifest with some instructions. Make sure to constantly look at those instructions and make sure that what's deployed actually adheres to that. And that is my super duper quick introduction to containers and Kubernetes. If you have any questions, feel free to reach out to me. Again, that's my name. Hold up. Last name Ekdal. You can find me on LinkedIn. I have a repo with everything that I showed you here. And with that, I'll see you next Wednesday. Next Wednesday, I'm going to talk a bit about continuous integration and continuous delivery, CI/CD. Thank you very much.